Ever feel like you're drowning in all this AI stuff and how these large language models are getting so good, so helpful?
Yeah.
You sent over some cool research about that.
Yeah.
Specifically how they learn, the reward model thing.
Yeah.
Seems like common sense, right? The better a reward model is at figuring out what we humans prefer, the better it should be at teaching the AI. But this paper, Razin et al., 2025.
Right.
It suggests that something else might be even more important for effective learning, something called reward variance.
Yeah. For anyone who maybe hasn't been following along, reinforcement learning from human feedback, or RLHF, is basically about teaching an AI what we humans like.
Yeah.
And it's like a two-step process. First, we train a reward model to understand what those preferences are. Then we use that model as like a teacher to fine-tune the language model. The paper you sent over, Razin et al., 2025. That's what it's all about. What makes a reward model a good teacher?
Okay, so let's unpack this. How we typically evaluate these reward models comes down to accuracy, doesn't it?
Exactly. So the way we typically evaluate reward models is by their accuracy in ranking different outputs according to human preferences.
Okay.
So if you give the language model a prompt, and it spits out a couple of answers, and humans overwhelmingly prefer one of them,
Right.
a really accurate reward model will also rank that preferred answer higher.
Got it.
And the accuracy is basically just the proportion of output pairs the reward model ranks correctly compared to a ground truth. That represents ideal human preferences.
So basically, if you give a language model a prompt and it gives you two answers, and most humans prefer one answer, a very accurate reward model should also prefer that same answer. And the accuracy score just means how often it gets those rankings right.
Exactly. It's like the most intuitive way to think about it. A reward model that is better at aligning with what humans want should theoretically lead to a language model that's also better aligned, after RLHF.
Okay, but here's where it gets really interesting. The paper mentions that, surprisingly, more accurate reward models don't always lead to better language models after RLHF. In fact, they cite several papers, 38, 10, 81 on this. It's like having a student that aces all the tests, but then can't teach the material to anybody else.
That is such a good analogy. That's exactly the central puzzle the researchers are trying to figure out, right? If just being accurate isn't enough, what else matters about a reward model? What makes it a good teacher for RLHF?
Yeah, and this is where reward variance comes in. Can we break that down? What is reward variance in this context?
So imagine, a teacher grading essays. And the teacher gives pretty much every student kind of the same grade, let's say a B+ or an A. It's really hard to tell who actually did a great job and who just met expectations.
Yeah.
There's not much variance in the grades.
Right.
In the same way, low reward variance in a reward model means that it's giving very similar scores to different outputs the language model might generate. It's not really distinguishing between outputs that are amazing versus ones that are just okay.
So even if it knows one is slightly better than the other, if the scores are really close together, the AI isn't getting a strong signal about how to actually improve.
Exactly. And so reward variance, the way they define it in this paper, measures how well the reward model separates the rewards of outputs that the language model is likely to produce. Like, it's not just about distinguishing good outputs from bad outputs in general. It's about how well it separates outputs within the space that the current language model tends to generate.
And that low variance can lead to something the paper calls a flat objective landscape, which doesn't sound good.
No, not good.
What does that even mean?
Okay, so imagine you're trying to find the highest point on some landscape, right? If that landscape has a lot of variation, hills and valleys, it's pretty obvious which way is up.
Yeah.
But imagine that landscape is totally flat. Even if you know the direction of the highest point, it's going to be super slow to make progress. And frustrating.
I would imagine so, yeah. So the objective here is what the language model is trying to maximize during training.
Right.
The expected reward it's going to get from the reward model.
Yes. So there's this RLHF objective function. It's equation 1 in the paper.
Yeah.
And it's basically maximizing the reward from the reward model. And it's also adjusted by this thing called a KL divergence penalty.
Okay.
Which prevents the language model from drifting too far from the original distribution, like after we start fine-tuning it with the reward model. And so the researchers in this paper show that if the reward variance is low, it's essentially making the slopes of this objective landscape very shallow.
I see. And those slopes are what the AI uses to learn. using those policy gradient methods like PPO and RLOO.
Exactly. So these policy gradient methods, they're what the AI is using to update its parameters based on the feedback it's getting. And so if the slope is basically flat because of low reward variance, even if the reward model is accurately ranking the outputs, it's not going to provide a strong enough signal for efficient learning. The AI is just wandering around this flat landscape, not really improving much.
So a reward model could be perfectly accurate but still be a bad teacher because it just doesn't provide a clear enough signal for the AI to learn from.
Exactly. And that really highlights that reward variance and accuracy, they're capturing two different things, two important aspects of a reward model. Accuracy is about aligning with the ideal human preferences.
Right.
But variance is really about the strength of the learning signal. You can see that in Figure 1 of the paper, which depicts both accuracy and variance as factors impacting RLHF.
Okay, but what about low accuracy? The paper talks about reward hacking. What's that all about?
Yeah, so if the reward model isn't accurate, if it's not reflecting human preferences, the AI might learn to exploit those flaws in the reward model and get high rewards without actually improving.
Oh.
So it's like, reward hacking.
Okay, so accuracy is still important.
Yes, accuracy is very important.
We need both.
Yes, we need enough accuracy to make sure the AI is moving in the right direction, but then we need enough variance so it can actually learn effectively.
So what are the implications of all this?
So this leads to some interesting implications, which they actually prove in the paper. The first is that, as we've been discussing, more accurate reward models aren't necessarily better teachers because variance is not directly tied to accuracy.
Okay, yeah, makes sense.
And the second is that the best reward model for one language model might not be the best reward model for another language model.
Oh, interesting.
The same reward model can have high variance on one language model and low variance on another language model.
So like if the outputs from two different language models are very different, the same reward model might be much better at distinguishing between good and bad outputs from one of those models compared to the other one.
Exactly. The point is that the effectiveness of a reward model depends on the language model. It's not just an intrinsic property of the reward model itself. It's about the interaction between the two.
And they didn't just theorize about all of this. The paper actually has experiments, right, with real AI models.
Yeah. So they tested this with, relatively large language models, up to 8 billion parameters from the Pythia and Llama families.
Wow.
And they used standard data sets like Alpaca Farm and Ultra Feedback. And what they found, one of the really interesting findings is that even when you have access to, like a really good ground truth reward, what they call Armor M, using a proxy reward model that is maybe not as accurate but has higher variance can lead to faster learning.
Wait, so a teacher that's not perfectly aligned with the, ideal answer but gives clearer feedback can sometimes help the student learn faster than a perfect teacher that gives less clear feedback.
Yeah, that's right. It's pretty counterintuitive, but yeah. In their experiments, they used something called reward normalization to make sure the scales of the rewards are comparable. And they mainly used the RLO policy gradient method.
So they found that reward variance was correlated with the actual increase in reward during training.
Yes, exactly. Even when they intentionally varied the accuracy of the reward model, they used these different reward models, like 100% on policy accuracy, 75%, 50%, and so on.
Okay.
And they found that the reward variance correlated with the reward increase. They also looked at off-policy accuracy, which is accuracy measured on data that's different from what the current language model is producing. And that turned out to be less predictive of how effective the reward model would be as a teacher. So it seems like what really matters is the reward model's behavior on the actual data that the current language model is producing.
So the paper also mentions reward ensembling, which is basically combining multiple reward models, right?
Yes.
How does this idea of variance connect to that?
They suggest that reward ensembling might be one way to get around this flat objective landscape problem, because if you're combining signals from multiple reward models, you're less likely to end up with low variance overall.
So what are some of the open questions and future directions from this research?
Well, one of the big questions is, how do you design reward models to have higher variance without causing other problems, like without making the reward signal too noisy? And in the paper, they briefly talk about this idea of encouraging a larger margin between rewards during training. But it's still an open question how to do that effectively.
So this whole variance thing, it's not just about like reward models that are trained on human feedback. The paper mentions how this could be important for other types of reward models, like for math or coding.
Yeah, so this general idea that variance is important for efficient optimization, applies more broadly, even beyond reward models learned from human preferences. It could be helpful in designing better reward functions for things like math and coding, where, correctness is more easily defined.
And the last thing the paper mentions is that, the ideal reward model, like the right balance between accuracy and variance, might actually depend on the specific alignment method that you're using, not just the language model.
Yeah, so they point out that while variance seems to be very important for RLHF, there are other alignment methods like best of n, where you just generate a bunch of different outputs and pick the one with the highest reward, and in those cases, perfect accuracy is actually optimal. So this really highlights that there's no single definition of a good reward model. It really depends on how you're using it.
So, yeah, it seems like accuracy is definitely important for making sure the AI is heading in the right direction, towards what humans want. But how quickly and effectively the AI learns really depends on this reward variance thing. A reward model that gives a clear distinction between, good and bad outputs, even if it's not perfectly accurate all the time, can be a much better teacher for RLHF.
It is surprising, isn't it, that sometimes a model that's less accurate can actually be a better teacher, because it provides a stronger, clearer learning signal.
Makes you think we need to change how we evaluate these reward models. Focusing only on accuracy in these benchmark tests might not be enough. And it's really interesting that the best reward model isn't just like an objective thing. It depends on the language model you're trying to train.
It's almost like, every student needs a different kind of teacher.
Right. Exactly.
And maybe a teacher who's perfect for one student might not be so good for another.
Yeah, this is really making me think, how are we going to design these reward models going forward? How do we balance accuracy and variance and all these other things to create truly effective teachers for AI systems? What does this tell us about how feedback works in general?
Yeah, big questions.
Lots to think about as this field keeps advancing. Thanks for diving into this research with me.
Yeah, this was fun.
Until next time.